video, I'm going to show you how to complete Venn diagram exam questions. So in the first question, we're told that there are 50 students in a group. 34 of those students have a mobile phone, 39 have a computer, and 5 have no mobile phone and no computer. So we have to use this information to complete the Venn diagram down here. So that just means filling in the number of students along the dotted lines, okay? So circle M or set M includes all the students that own a mobile phone. Set C includes all the students that own a computer. In the intersection part where it overlaps, this lies within circle M but also in circle C. So this includes the students that own both a mobile phone and a computer. And lastly, outside the circle, well, they're the students that don't own a mobile phone and don't own a computer. And we're actually told this number of students already here in the question. Okay, 5 students have no phone, no computer, so you can fill in that number first outside the circles, okay? Now, if we go back to this intersection part, the number of students that own both a phone and a computer, we're not told that in the question, okay? So we don't know this number of students. So for the moment, I'm just going to write the value of x, okay? Now, 34 students have a mobile phone. So I'm just going to write 34 in here. But we can't just leave it as 34 because some of those students out of those 34 maybe own a computer as well. So some of those 34 students might lie in the intersection part. So what you have to do here, for the moment, is write 34 minus x, which makes sense because if you add this expression to the number here, x, the x's cancel each other out and you're left with 34 within set M, which is the number of students with a mobile phone. So I'm going to do the same thing for the other set. 39 students have a computer, but I have to remember to subtract the intersection because some of those 39 students can lie within the intersection, and if I add this expression to positive x, the x's cancel and I'm left with 39 students. So from here we have to form an equation to solve and find the value of x. So we're told at the beginning of the question there are 50 students altogether. So if you add all of the students in circle M and C and the students outside the circles, they should come to a total of 50, okay? Because that's the total number of students. So that's what I'm going to do. I'm going to add everything together and put it equal to 50, and that's how I'm going to form an equation that we're then going to solve. So 34 minus x plus the middle intersection x plus 39 minus x plus the 5 students outside the circles has to equal a total of 50. Okay, so I can simplify this. Negative x plus x is 0, so those terms cancel each other out. 34 plus 39 plus 5 is 78. So I have 78 minus x is equal to 50. Then maybe you can just see what the value of x is, but if you're not sure what it is, I'm going to move the x term over to the right and the 50 over to the left so that I have 78 take away 50 is equal to x. So if I subtract 50 from 78, I get 28. So x is 28, and remember x is the intersection. So 28 students own both a mobile phone and a computer. Okay, so I'm just going to rub out the value of x here and change it to 28. And now we can work out the numbers that go on the left and the right here too. Because x is 28, I have to subtract 28 from 34, which gives me 6. So they're the number of students that own just a mobile phone. Okay, I'm just going to cross this out now. And I'm going to do the same thing over here on the right. I'm going to subtract 28 from 39, which is 11. So 11 students own just a computer, but not a phone. Okay, so now we've completed the Venn diagram. I would just erase your calculation just so it's clear which numbers are your final numbers, and that's completing the Venn diagram. that the universal set consists of natural numbers smaller than or equal to 16. So natural numbers are positive integers starting with the number 1, so 1, 2, 3, 4, all the way up to and including number 16, okay? So from those numbers, we have to start by writing down all the square numbers. So the square numbers will be 1, 4, 9 and 16, because 1 squared is 1, 2 squared is 4, 3 squared is 9 and 4 squared is 16. Okay, so that's part 1. In part 2, we have to write down the 6 prime numbers. So prime numbers are numbers which only have 2 factors, 1 and itself. The first prime number is 2, and that falls between 1 and 16, so I'm going to write that one down first. Okay, 1 is not a prime number. Okay, the next prime number is 3. Next it will be 5. Next we've got 7, 8, 9, 10, 11, 12, 13, and I've got 6 prime numbers there. Okay, so all of these numbers are prime because they only have 2 factors, 1 and itself. If I just take another number from 1 to 16, for example 10, you know this is not a prime number because it has more than 2 factors. You can do 1 times 10, but you can also do 2 times 5 in order to get 10. So that is not a prime number, okay? So that's part 2. Now, on part 3, we're told that set M, so circle M down here in the Venn diagram, consists of all multiples of 3, okay? Within those numbers 1 to 16, okay? Set F, so circle F, consists of all factors of 15, okay, from 1 to 16 again. So before I complete the Venn diagram, I'm just going to write down from 1 to 16 all the multiples of 3. Now, multiples of 3 are just the numbers in the 3 times table. So 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12, and 5 times 3 is 15. So they're all the multiples of 3 from 1 to 16. Next, we've got factors of 15. So these are the numbers that you multiply together in order to get the number 15, okay? So if I write them down in pairs, I've got 1 and 15, because 1 times 15 is 15, and I've got another pair, 3 and 5, because 3 times 5 is also 15, okay? So they're the only factors of 15, okay, between 1 and 16, okay? Not that actually is important to this one. Okay, now, let's look at the Venn diagram. I actually made it a little bit more difficult. I know they filled some numbers in for us in the exam question, but I thought we'd start from scratch just to get some extra practice. Okay, so we're going to go through all the numbers from 1 to 16 and fill them in on the Venn diagram, okay? So let's start with number 1. Now, number 1, we can see, is a factor of 15. It's not a multiple of 3, so it lies in set F. So you have to write the number 1 inside circle F, so I'm going to write it here. Make sure you don't write it in the overlap, because that would be in circle M as well, and it's not in circle M, it's not in set M, it's not a multiple of 3, okay? Next we've got the number 2. So 2 is not a multiple of 3, it's not a factor of 15, so because it doesn't lie in either of those sets, we have to write the number 2 outside the 2 circles, okay? Number 3, it's a multiple of 3 and it's also a factor of 15. So it has to fall in both sets, M and F. So this one you would write on the intersection, okay? Number 4, it's neither a multiple nor a factor. So this is another one you need to write down outside the circles. Number 5 is a factor of 15, but it's not a multiple of 3. So you need to make sure it lies in only circle F. So I'm going to write number 5 here. Number 6 is a multiple of 3, it's not a factor of 15, so this time you have to make sure it lies only in circle N, so we're going to do number 6 over here. Number 7 doesn't lie in M or F, so this one also goes outside the circles. Number 8 also lies outside the circles, as it's not a multiple, it's not a factor. Number 9, however, is a multiple of 3. Okay, so you need to make sure that this number lies in set M. So I'm going to put number 9 here. Number 10 is not a multiple of 3, it's not a factor of 15, so this one also goes outside the circles. Number 11, likewise. And number 12 is a multiple of 3, not a factor of 15, so it needs to go in circle M, okay? So there's number 12. Number 13 is not a multiple of 3, it's not a factor of 15, so this one goes outside the 2 circles. Number 14 doesn't lie in M or F either, so this one goes here too. Number 15 though is a multiple of 3 and it's also a factor of 15. So because it lies in both sets, this is another number you need to write on the intersection here. Okay, so that it lies in both circles. And last but not least, number 16 is not a multiple of 3, it's not a factor of 15, so it goes outside set M and F. So in the next part of this question, in part B, it says write down the odd numbers that are not in set M and not in set F. So if they're not in set M and not in set F, we're interested in the numbers around the outside the circles. Okay, so if we look at those numbers and we write down all the numbers that are odd, 7 is an odd number, so there's the first one. 13 is an odd number, so there's another one. 11 is also odd, and that's it. Okay, so they are the odd numbers for part B. Now on part C, it says find n brackets M intersection F. Okay, so this symbol here means the intersection, so the overlapping part of sets M and F. And this letter N means find the number of elements that lie here. Okay, so on the intersection. So if you look at the intersection part here, you can see there are 2 numbers, 3 and 15. So the number of elements within the intersection is 2. Okay, and if there had been 3 numbers here, you would write 3 and so on. Now in part D, it says a number is chosen from the universal set, so from all the numbers here on the diagram, and we have to find the probability that it is in set F. So you have to start by counting how many numbers fall in set F. So I can see there are 4 numbers in circle F. Then you need to write that number out of the total numbers in the universal set, because the number we're choosing at random is from the universal set, so you need the total number altogether, which is 16. Remember, there are 16 numbers altogether. So the probability is 4 out of 16, and if you want to simplify it, you could write a quarter, you could also write 0.25 or 25%, as long as it's a probability, then that is correct. So in the next exam question, we're told there's a group of 120 students, and those students sit maths and English tests. We know that 61 students passed the maths test, 27 students passed both maths and English, and 19 students do not pass maths and they do not pass English, okay? We have to use this information to complete the Venn diagram down here. So circle M is going to include all the students that pass maths, and circle E is going to include all the students that pass English, okay? So let's see what information we can put onto our diagram from up here. Okay, if we start with this part here, 27 pass both maths and English. So those 27 students are going to lie on the intersection, because the intersection lies in circle M, so all the students that pass maths, and it also lies in circle E, all the students that pass English. So the ones that pass both have to be written on the intersection. Okay, so that part we've written on. Here we have the number of students, 19, that don't pass maths and they don't pass English. So they're the students that don't lie in circle M, they don't lie in circle E, so they have to go outside the circles here. Okay? Next, if we look at this information here, we're told that 61 students pass maths. Okay, so be careful, you can't just write 61 here. Because if you look now on the diagram, in circle M you have 61 plus 27, which is more than 61. You have to remember to subtract the intersection from that number to work out, so that's 34, the number of students that pass only maths. And that makes sense now, because if you add 34 and 27, you get 61, which is the number of students that pass maths. So here, when they tell us how many pass maths, they don't specify how many pass just maths, okay? You have to work that out yourself, okay? So we've nearly finished. We have to also work out the number of students that pass only English. Okay, so we've run out of information here, but we do know the total number of students. So when you add all of these numbers together, here, 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 and here, they should come to a total of 120. So if we call this number here x, when you add 34, 27, x, and 19, they should come to 120. So you can form an equation to work out the value of x. Okay, so if I add those together, it equals 120. All you have to do to work out the value of x is subtract 34, 27, and 19 from 120, and that will give you the value of x. Okay, so when you do that, you should get 40. Okay, so that is the number of students that passed only English. Okay, and then something you can just do at the end, just to make sure you've done it correctly, is just add all those numbers up, just to make sure they come to 120, which they do. So in part 2 of this same question, it says find n brackets e. Remember, when you see n in front of the brackets, it means find the number of elements in this set. Okay, so in this set, e. Okay, so in this question, we're talking about students. So it means find the number of students that are in set E, i.e. the students that passed English. So I can see here there were 40 students that passed just English and 27 students that passed maths and English. So to work out all the students that passed English, you have to add these numbers together. Okay, so 27 plus 40 is 67. So that is the answer to part 2. A baker asks his customers whether they like lemon cake or chocolate cake, and these are his responses. Okay, so I've just written down the first letter of all the names just to speed things up. Okay, so in this circle here, set L, this includes all the people that said they like lemon cake, and then in this circle C, this includes all the people that like chocolate cake. In the middle here, the intersection part of the two sets, these are the people that like both lemon cake and chocolate cake, and we can see there's one person outside the sets. This person doesn't like lemon cake, doesn't like chocolate cake, okay? So, part 1, we have to work out n, and then inside the brackets we have the universal set symbol, okay? That means everyone all together. So n means the number of elements, so we're trying to work out the number of customers all together, okay, on our diagram. So to work that out, you would just count all the names, and you should find there are 12 customers all together. So you would just write 12 for part 1. Now, on part 2, it says, write down the fraction who like lemon cake or chocolate cake, but not both. Okay, so remember these two people here on the intersection are the people that like both lemon cake and chocolate cake. So we don't want to count those. We only want to count the people who like just lemon cake or just chocolate cake. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So that's the number of customers, but we have to write down the fraction. So the fraction is always out of the total. Okay? So we know the total number of customers. The total number of customers we worked out in part 1, it was 12. So the fraction is 9 out of 12. And if you want to simplify the fraction, you could also write 3/4. Okay, so that's part 2. Now, on part 3, we have to use set notation to complete this statement. Okay, so I can see these names beginning with J and N, they lie on the intersection. Okay, so I have to use the intersection symbol, which is like this. And they lie on the intersection of set L and C. So you need to write down the letters L and C, and it doesn't matter if you write them the other way around, and that's all you have to do for part 3, okay? Number 4, what does the Venn diagram say about T? Okay, so this is the person with a name beginning with T. I think I mentioned this at the start. This person does not like lemon cake and does not like chocolate cake. So that's all you would write for part 4, okay?